All right, well, good morning, everyone. Thank you for joining FlexTrain. So this morning, we're going to start talking a series about doing load calculations and duct design. So the entire month, we're going to look at how to administer load calculations and how to design the ductwork that goes along with that. We're not going to dive extremely deep into it. We're going to start at, 1,000-foot view, and we're going to work our way down so that we at least have a principle of understanding. Because when it comes to load calculations, it's not a simple thing. There's a lot that goes into understanding what load calculations are and the accuracy that we need to have for those. So when I do an actual load calculation class, it's an entire day worth of sitting down and understanding load calculations, in the same way with duct design. But we're at least going to brush some topics. So if we look at load calculations, to understand how to do that, we're going to need the tools, right? So if we talk about load calculations, we're going to step back a little bit and talk about where it all came from. And I'm going to show a little bit of my age. So if any of you out there have seen this, you're going to understand that in the older days, everything was manually calculated. So if we did a heat load calculation on a structure, this is a typical form that we would start with. So in a manual load calculation, we're going to end up with an entire house load calculation, but we're going to have to start by doing individual rooms. So I would have, maybe bedroom 1, and I would have bedroom 2, and I would break down each one of those based on the construction, based on the occupants, and based on the size. So we'd have a lot of variables that go into that. We have to look at what type of wall construction, what directions those walls face, what type of windows and glass we used. There's a lot of factors that goes into doing a manual calculation. But at the end of that calculation, we're now going to have a heating and cooling load for my structure that is pretty accurate. So then I have the ability to select my equipment based on what my true heating and cooling loads are. And that's really the way that we do it. Unfortunately, a lot of times in our industry, we have people that'll ballpark it. They'll look at a structure and they'll come up with a number and go, I've used this size of equipment in the past and it worked on a structure about approximately this size. And so that's what we're going to go with. Well, as we are starting to focus more on proper load construction and proper equipment matchup, it is very critical to do an actual heat load calculation. So in some jurisdictions, it's required to have a manual J load calculation to be able to install a piece of equipment in a structure for new construction and for equipment replacement. So we're going to start seeing a lot more of that. And I actually had a conversation with a contractor here in Indianapolis where that is not required, but I had a contractor that he does a manual load calculation on every job they go on. Every estimate gets a load calculation, either a manual on a new construction or it gets an automated on an equipment replacement, just to verify that the proper size equipment is going in. Because as contractors, we've seen in the past, and technicians, many times we went to a house and looked at a piece of equipment, found a high temperature rise, just to realize that the original piece of equipment that was installed that matched that ductwork has been replaced and upsized to something else without the ductwork being adjusted to match the equipment. So it's a good idea to do those calculations. And as technology has changed, it's actually made it much easier for us. So we have tools now that are not just pencil and paper manual calculations that can get us in the place that we need to be to see what size of equipment is proper for our structure and our load. So there's a lot of references that this comes from, and these are references that I encourage you to do research on, spend time with. One of them is the U.S. Department of Energy. They build the strategy guideline, which is an accurate heating and cooling load calculations manual, and it's updated regularly. So it gives you a lot of references of proper applications. We also have ASHRAE. We all know ASHRAE is air quality standards, and they have their own publications that helps us make sure that we're getting proper air changeovers and that we're sizing the equipment to handle new applications that we have for air quality standards, so that we're providing enough air, we're providing enough backup heating and cooling loads to compensate for these additional air changeovers. Because sometimes now we're bringing in outside air so that we have proper air changeovers in our structure. So ASHRAE is a really good resource for that. ACA is pretty much the one that started it all. So when I go back to a lot of my manual load calculations, ACCO was who actually introduced those manual J load calculations. And people asked about, well, what's the difference between manual J and manual D and manual S? I was like, well, in our old days, we had a binder. And the first book in the binder was A. So that was manual A. The second one was B. That was manual B. We just rolled through our catalog until we got to the proper manuals for what we were doing in HVAC. So back to manual J, that was where we did our actual calculations. Manual D is where we did our duct design, and we'll go through duct design and what we're doing there. ESCO is a really good resource for education and certification. So ESCO even has a 100 question exam that has a accompanying certificate for it to help, to help see your proficiency in manual and automated load calculations. So highly recommended. Our friends at ESCO have been doing a really good job of providing education and certifications. So if you're looking for a certification in HVAC load calculation, ESCO is a place to go, in my opinion. I'm sure there's more out there, but ESCO is just good quality information and education. So what are we doing with load calculation? Well, we're going to start with a structure. And with that structure, the goal is to end up having equipment and having properly sized ductwork. So to do that, we have to start with a very, very basic fundamentals. We have to look at our total structure. We have to look at the construction of that. So we're going to be looking at outside walls. We're going to be looking at windows. We're going to be looking at doors. We're going to be looking at occupants, because we don't always think about that. But as humans, we produce a lot of heat. So we have to look at how many occupants are in our facilities. We have to look at what type of appliances are going to be in our facilities. We have to look at how large of a TV we have in here, because we don't always think about that. But that television is using wattage and emitting heat as it's running. Also is our computers that are in these facilities as well. Lots of different things that add heat loads to our structure, and the construction of the material alone will affect our heat absorption and heat rejection. And it is going to make a big difference on the amount of equipment that you can put into a facility. I was looking at reading an article this week, and it was talking about how a 1,500 square foot residential structure has changed in the last 50 years. So 50 years ago, if you had a 1,500 square foot home, you looked at that as a CFM per square foot, and you would look at 1,500 square feet. I needed about 1,500 CFM. So that thing could very realistically end up with a 100,000 BTU furnace and a 3 to 4 ton air conditioner. Today, you can create the exact same 1,500 square foot home that can run on 5,000 BTUs. If the proper materials are used for it. Now we're talking about using R30 walls, and we're talking about using R90 ceilings, and we're talking about low E windows that are triple pane. We're talking about very expensive materials, but we can actually produce a 1,500 square foot home that can be cooled on 5,000 BTUs. Big difference from what we did from our previous calculations, right? So it's all about understanding the materials that we're using and how much heat we're gaining and how much heat we are rejecting. So if we look at a true manual J, there's a lot of data that goes into that. We have to look at the zone. We have to look at our climate zone that we're in. We look at our construction. We look at how much air exchanges. And for those jurisdictions that are looking for a true manual J calculation, this is what they expect. They want to know the actual CFM and the actual duct sizing per room. So not only are we going to design the system for our total structure, but we are going to then break it down into our individual rooms so that we have proper airflow in each one of those. So a lot of data that goes into doing these calculations, and it's going to be based on your area outdoor dry bulb, your indoor wet bulb, total capacity. We're going to look at about sensible heat calculations, and then we're actually going to start selecting equipment, and then we'll end up designing ductwork based on how much static pressure that we want on that. But we're not going to do that just yet. We're going to save that for another week. So if we look at our structure and we talk about things that go into the factoring of heat loss that may not be thought about, we have things like the loss through our exposed walls, through our roof and ceilings, through our basement floors, which a lot of people don't think about that. If we just put concrete in the ground, we don't have an insulated structure. We have earth on earth foundation. So we're now looking at putting barriers in between our earth to earth foundations, putting insulation in between our concrete and our earth to be able to increase that efficiency so that we're not losing through our basement floors. Of course, we always have windows, doors, and cracks in our structures. You know, one of my early homes that I had was built in 1908 and had no insulation in any of the walls in 2 stories. You know, we don't think about those things. You know, sometimes we'll look at a structure and go, well, that's a pretty nice looking home. Well, how is it actually constructed? What's inside of those walls? What kind of windows and doors are on that? How big are the cracks in that thing? Can I hear the wind blow when it's breezy outside? So a lot of infiltration through windows, doors, and cracks. We also look at our below grade walls if we're talking about just, you know, crawl spaces. And we're also going to start looking at knee walls, attic knee walls that sometimes are very much left out and only insulated with what's insulated on the walls. If I have a wall downstairs that has R13 insulation in a 2x4 wall and I get into an attic where it is now just a knee wall, sometimes that thing's only going to get an R13 insulation because it's a 2x4 stud. So we're looking at things that we can do to improve our insulation factors by increasing knee wall sizing so that we have proper insulation in the areas that need it. If we talk about our heat gain, well, some of them are the same, but then we have some additional, right? We've got people, we've got appliances, we've got makeup air units that we're having to bring in outside air to be able to get proper air exchanges inside of our structure. So to do that, and especially if we're talking about in the summertime, I'm bringing in hot, humid outside air to help make up my air exchanges. Now I have to cool and dehumidify that air once it gets inside of my structure. If I'm talking about an 80% gas furnace, I have a draft system that is venting straight outside. So any air that is moving through my draft is now going to be infiltrated from my windows, doors, cracks in my structure. So I have an additional load. We have a lot more computers in our structures today than we had 50 years ago. We had a lot more devices that need to be charged, like cell phones. And so we have a difference in load, and we have to understand what that load is on our structure. So the things that are the tools that are the most common in our industry, and I know there's going to be people that are going to come back and go, well, this one works great too, and this one works great too, and I'm sure there are a lot of different programs. So I'm just going to brush on the ones that are the most popular that I encounter in the field. So one of them is Load Calc. Load Calc is a digital load calculating, so it's a software, and it's completely based on your regions. So I'm going to go in, I'm going to select my state, and I'm going to select my city, and then I'm going to start adding all my structural components. I'm going to add in what my walls are constructed of, what my windows are constructed of, my doors, my roofing, my subflooring, and I'm going to add all that in, and this is going to calculate it out for us. Probably the most popular and the one that is on the greatest increase in use is the Service Titan function, because a lot of contractors are now using Service Titan for all of their documentation, for their work orders and for their billing and for their travel information. So now we can add all of that into one package. So that one ticket, that one reference for our customer has all of their call information, all of their estimates, all of their load calculations, all in one area. And so it's the same principle. So while we're in Service Titan, we have a service ticket open for our customer. Now we can go into our load calculation section of Service Titan. We can go to our region. We can start inputting some of our dimensions, so our size of our structure. We can start talking about insulation grade, sun exposure, and then we can actually calculate a load for our structure based on its location right in our service ticket. So very, very, very handy function to have. One that's been around for quite a while because it caters to all load calculations, residential, commercial, industrial, is the WRIGHTSOFT programs. So WRIGHTSOFT allows you to not only do your load calculations, but start doing CAD designs for all of your ductwork once you get to that point. So if you're doing commercial applications, you're going to find that WRIGHTSOFT is probably the software that's going to suit you best. because we can now do a physical representation of all of our inputs. Very powerful software. We also use Cool Calc, which is probably one of the most interesting functions that I've seen yet for load calculations. So Cool Calc is it's a remote-based program. So we're actually going to run it through our mobile device. So as salespeople, as sales techs, this is the device that you're going to find probably the handiest. So from your mobile device, you're actually going to pull local information on that structure based on data that's been inputted for their typically taxes. So it's going to pull local information. It's going to pull how much square footage has been reported, how much, what your general construction design is, what your elevation is. And so it's going to pull that data along with the GPS photo along with that. So you can make additions to it, especially if you're doing like a room addition and you're wanting an overhead view of what that structure is going to look like. We can start with the original load calculation, which is it's not an exact load calculation, but it's a very quick, very accurate calculation. Then if we need a true load calculation, we're still going to have to go back and do some manual input, but we can do a very fast, like within a minute, general calculation on that structure and get some ideas, because it can also pull up utility information and look at average utilities for that structure as well. So a lot of information that can be grabbed in a very, very short period of time. A lot of people don't even realize that even here at Johnstone Supply, we have load calculation software right on our website. So when you go into our tool section, we have an AC load calculator where we're going to look at our structure. We're going to pick the design of the structure. We're going to start picking insulation. We're going to just put in general information. It's not as specific as some of these other load calculation tools, but it gets us in the ballpark. So we can input all of our information, and then it will actually spit out a general calculation for our structure based on BTUs, based on CFM and tonnage. So a lot of tools that you can use besides our old manual J paper and pencil calculations, but that's what I did for a majority of my career. I manually calculated the things that I was working on. It wasn't until probably the last 10 to 15 years that we've had any type of electronic load calculation capabilities. In the last 5 years, well, we've seen what's really happened with that. I can now take my mobile device, enter in an address, and have a lot of data for that particular home and structure. So lots of tools out there, and I hope that simplifies some of the access that we have to load calculation tools. And as we start moving into load calculation and duct design, we'll dive into some of the functionality of each one of them. But I just wanted to give everyone a 1,000-foot view on load calculations. Anybody have any questions or comments? Okay, well, thank everyone for joining us, and we shall see you next week.
Thanks, Clifton.
Thank you.